Okay, you're all ready.
All right. Thanks everybody for coming out. Thanks for the opportunity to talk. I appreciate it. The warm welcome from Eric and Alex. And this is my first time speaking to JSLou, but I am a frequent speaker in the area. I'm the actual organizer for the Java Users Group. I'm a co-organizer for the Open Source Society, Kentucky Open Source Society. JavaScript on top of the JVM. And so the Java language itself, I'll agree there's some problems. It's a little verbose, there's some missing syntactic sugar that we'd all like to have. But you can actually use JavaScript and a bunch of other languages on top of the JVM. So who am I? As I said earlier, I'm Devin Phillips. I'm a software engineer with about 20 plus years of experience. I'm a polyglot programmer. I work in almost every language you can probably imagine. And I am a DevOps believer. That means that I like to write code, build code, deploy code, package code, operate code, monitor code. I think it's incipient upon all of us to be able to run our code in production. So in this group, I'm pretty sure we can assume everybody here likes JavaScript. Yep? Yeah, okay, great. There's great things about JavaScript. It's really good for rapid prototyping. The same language, you can use it for your back end and your front end. That's really powerful. And it's event-driven, non-blocking. Those are really powerful tools. But JavaScript isn't the only language that has those capabilities these days. And that said, if we're being honest, JavaScript isn't perfect. So NPM has issues, namespacing, library conflict or naming conflicts, other problems. Node.js is only a single process. It doesn't really do threading, even though under the hood it does do some threading. Some of the libraries have been having lots of security issues lately. We've all seen what happened with Graceful FS in the last year and a half. It has some missing capabilities, specifically threading, clustering, good message handling. And sometimes you really do want strong typing. But there's a compromise. Since Java 1.4, the Java virtual machine has had a JavaScript interpreter. The original JavaScript interpreter was contributed by Mozilla. It was called Rhino. And it was rewritten and reintroduced in Java 8 using a new engine that takes advantage of a new bytecode instruction called invoke dynamic that allows dynamic languages to run at full JVM performance on top of the JVM. And so the new JavaScript engine is called Nashorn, which is the German word for rhino. And so what you get in the JavaScript, or in the Java world, just because you're running on top of the JVM, you get one of the best multi-threaded environments for programming available to software engineers these days. Plus, the Java ecosystem, it has billions, literally billions of libraries that you can access very quickly, very easily, from Maven Central or from Bintray or whatever artifact repository you want to access. And more. So JavaScript's been getting a lot of really good mindshare these days, and so the Java ecosystem has adapted to that. And so there's a lot of toolkits which make JavaScript a first-class citizen on top of the JVM. Tools like Vertex, Camel, Nashorn, Ceylon, Scala.js, ClojureScript. These are all JVM-based technologies that allow you to leverage what you know about JavaScript and how you code in JavaScript and leverage the power of the Java virtual machine. And so what is the power of the Java virtual machine? Well, the libraries are the biggest part. There's libraries for everything in Java or on the JVM. And usually there's 10 or 12 different libraries for everything that you're interested in doing in different ways. Excellent multi-threading support, and probably most importantly is the just-in-time compiler. When you run an application on the JVM, if it stays running longer than a few minutes, the Java virtual machine starts to profile your code, and it will short-circuit paths that are never used, it will optimize your code, it will reduce memory, all without you having to change a thing. Memory management in the JVM is actually wonderful. The garbage collector, the heap, very fantastic, saves you a whole lot of time and hassle. And on top of that, you get access to a polyglot environment. Many, many languages can run on top of the JVM now, especially with the introduction of invoke dynamic. Ruby in JRuby, Python via Jython, Java, Scala, Clojure, you name it, you can run all of that on the JVM, even within a single application. So there's three ways that are easy ways to get started with JavaScript on the Java virtual machine. And the first is the Nashorn command line interface itself. It's called JJS. It's a command line JavaScript interpreter, so if you have a Node.js, a simple Node.js program, instead of just running node space index.js, you can run JJS space index.js and it'll run inside of the virtual machine. Now the startup time is a little slower than the V8 engine in Node, but if your code runs longer than 30 seconds or a minute, the JIT will optimize your code and it will run faster. And honestly, it's actually pretty good for scripting, especially if you need to make use of some of those Java libraries in your script. Another way is Vertex. And this is actually an open source project that I'm a contributor to. I'm actually interviewing to hopefully get a full-time job with Red Hat working on this product. But Vertex is a toolkit for building reactive applications on the Java virtual machine. It is event-based, it is non-blocking, and it is polyglot. So Vertex has support for like 9 different languages built right in. And the cool thing I think about Vertex is that you can have some parts of your code written in JavaScript, some parts written in Java, some parts written in Groovy, some parts written in Ruby, all within a single application. And all of those different components communicate using message passing, or what they call their event bus. Also, one of the things I really love about Vertex is it has clustering built in to the base code. So just by adding a -cluster flag to your startup of your Vertex application, it will discover any other Vertex nodes on the local network segment, and it will automatically extend the event bus across all of those nodes and allow you to send messages and do coding across multiple nodes on the network. That is super cool. And then finally, there's Nasvin. So we know that the JavaScript engine on Java on the JVM is called Nashorn. Well, in the Java world, the venerable way of doing project management, like the Java equivalent of NPM, is called Maven. Maven does quite a bit more than NPM, but Maven is definitely one of the ways to do that. And so you take Nashorn with Maven, you get Nasvin. Nasvin is really cool because you take a regular Node.js package.json file, and you put your code into it, and now you have not only access to a bunch of JavaScript libraries that you can include in your project, you can now include any Java library from Maven Central right into your application. This is sweet. This is really simple to use. I'll show you an example in a few minutes. So you can find that at github.com/Nasvin. And with that in mind, let's skip straight to a Nasvin application. So here's the package.json file, and really the only weird thing that you'll notice here is that in the dependencies section we have a subsection for Maven. And what this is telling Nasvin is that Okay, when you go to get these libraries, you're going to go out to Maven Central to get them. And the way this works is underneath the hood, it uses a Node.js application to generate a Maven project file that it caches, pulls down all of these libraries from Maven Central, and puts them into the class path for your application. And so what I did is I actually took an actual Java application that I wrote using Apache Camel and turned it into JavaScript. So normally in Java, the way you bring in libraries is you use an import statement and you use a fully qualified package name. Nasvin exposes that using this packages object. So you say packages dot fully qualified class name, and you assign it to a value. So now we can use things like log4j. We can use, what I'm using is a tool called Apache Camel, which has hundreds of components for doing application integration. And what I'm using it for is I'm pulling event-based data out of Twitter's API and streaming it through Apache Camel and doing transformations, storing a copy in the data. Follow it very easily, right? But imagine now you have access to all of these amazing packages for Java. This is, because it's in Apache Camel, is automatically multi-threaded and can scale very quickly and easily. Down, let me see if I can find it real quick. So you'll see here we have a parameter caller, concurrent consumers. I can jack that number as high as I want, or if I remove that component, it defaults to 500 concurrent consumers. That means you can have 500 streams processing in parallel on your machine. That may or may not be optimal depending on how many cores you have. So that's one way. Now, this is a simple Vertex application. And this is probably my favorite bit to show you because I'm going to show you that clustering. So Vertex, when you run, it has a command line tool just called Vertex. You say Vertex run and the name of your JavaScript file. And we're using Vertex to do a periodic event fire every 750 milliseconds. And it calls a Lambda function here. And on that Lambda function, every time this periodic fires, it sends a message on the event bus to this address, and it uses the node ID that it's getting from the environment variables. And what that looks like when you run it is tools bash npm run watch. Oh, actually I've got to say export node ID equals alpha. Of course, it's not going to cooperate. Let's do it here. Documents, JSLou. Nope. In the wrong place. Apologies, folks. Let's actually just do view, exit presentation mode, go down here to my terminal, and we'll say node underscore ID equals alpha. Sorry, that's hard to read. But all I'm really doing is running npm run watch. So this project is set up to use npm, and it has a watch target that watches all the files in the project. If I change one of the files, it'll reload the application automatically. And you'll see that every 750 milliseconds, it's outputting the name of the node ID that I exported in my event, or in my environment variable. So now I'm going to start up another instance. Oh, actually, I need to change that. It needs to be with the cluster. So Vertex run dash cluster source main.js. So now I've got that running in cluster mode. I can do the same thing. Node ID equals Bravo, Vertex run source main.js, and go put the cluster flag in there. And here in a second, you'll notice once it gets started up, it'll automatically discover other nodes on the network, and you'll see that the messages are passing between the two instances. Now this would work on the same machine or on separate machines within the same subnet. It uses multicast DNS to discover other nodes. And we can do this as many times as we want. So I can start up another one, node ID equals Charlie, vertex, run, cluster, source main. And a few seconds later when it starts up, we'll see Alpha Bravo Charlie flowing through the message queue, exactly as it should be. That's very powerful. So we can take vertex processes and put them in multiple nodes with multiple different types of code and what Vertex calls verticals. And verticals are guaranteed to be single-threaded. They communicate with each other over that event bus, which can be clustered across an entire network. And they are capable of running multiple threads. So how many of you have heard of the reactor pattern? Yeah? Okay, so if you've done any much Node.js development, the reactor pattern is that you have something that does something and does a callback to handle the results so that you're doing everything in a non-blocking manner. And it does, in Node.js, it does that using a single event thread. Vertex has multiple event threads, but it guarantees that each individual vertical is single-threaded when it runs unless you specifically tell it to override it for multi-threaded verticals. So you can take advantage of as many cores as you have available on your system, and Vertex will automatically scale to however many cores you have. That's the quick and dirty. Questions?
Yeah, can I get a copy of that presentation?
Absolutely. It's in Google Docs, and I'll even put the source code for all of these up on GitHub here in a little bit.
Yeah. The cluster across the network, how resilient is it to failures of other components?
It's actually very resilient. They
Looks like it's okay now. Maybe studio.
It's not really.
Can you pull it up?
Pull the stream up or?
Mm-hmm. Yeah. Oh, okay.
Don't worry about it.
What is it doing right now? Sorry, I'm having issues with the live stream stuff.
By the way, I appreciate what you guys have done with the Docker options with Elkstack lately. It's been really easy to get Elkstack
I'm
spun.
sorry.
Compose
I
files.
didn't even know we did.
It's getting better, yeah. So like at SunGuard we had deployed Elkstack about 3 months back
Yeah.
finally, and we just had a Docker compose file
That's what
and submitted it through Docker Swarm, so it spin up as many Elastic nodes or Logstash nodes or Grafana nodes as we needed.
So
Really
the
nice.
so now you're using the released image that we made.
Mm-hmm.
Yeah. Because a lot of people download from Docker itself, and it's not the right.
Oh, no, the one we got was from Docker Hub, but it
Oh,
was
okay.
the official image.
Oh, the official.
Yeah.
Okay. If you can show me.
Maybe. Well, I don't work there anymore, so I don't technically have access to it,
Okay.
but I think I've got the Docker
Have a
compose
terminal
file.
somewhere?
Yeah, there's a
Man, it's
few
gonna
Docker
take so
files
long
out
to,
there,
like,
and one is
get
sort of the
there.
official one that's maintained and actually updated, while the other ones are.
Well, we didn't actually use a Docker file. But nowadays,
You're live?
Okay. My name is Thomas. I work for Elastic. I'm a developer there, and I thought. The search box, if you type something in there, or in Wikipedia, the search box right here, if you type something in there, in the back, it will use Elasticsearch. So Elasticsearch is the indexer that you put in documents, and it then has an API that you can use as a web developer to actually search in with free text. The other thing that I might be useful for, and that's what I'll show because that's where I think the entire stack comes into play, is that so you have deployed your web application or whatever product is you have, and you want to sort of start analyzing traffic to it or your logs from it. Elasticsearch works well for that too. So if you have some sort of machine process that produces a lot of data, and then you want to derive insights from that data, Elasticsearch and Grafana and Logstash and Beats will help you with that as well. And want to do a live demo too to sort of give you a sense of how hard or how easy it is to get set up and started with this. And so you can always interrupt me too if you have questions, and I'll walk you through it. So when you go to Elastic, there's a products page, and it kind of looks like this. And it's basically a pamphlet about the stack. And in the center is Elasticsearch. As Search Engine and I talked about, that will do the indexing of the documents for you and expose the search APIs. And that, for example, you can use when you have search functionality on the site. On top of that sits Kibana, and that's the front-end product. It's basically a web application that you can use to look at your data in Elasticsearch and visualize your data in Elasticsearch. So I'll show you both these. But then, of course, you need to get data into Elasticsearch as well. And there you have two options. One is called Logstash, and the other one is called Beats. And they do very similar things. And Logstash is one way of doing it using the JVM, and Beats is another way of doing it using small Go applications. And I'll actually show Beats because it's very easy to get started with Beats. So let's download Elasticsearch.
Bless you.
So we're starting to download Elasticsearch. Elasticsearch is a JVM application, so you'll need to have Java installed on your computer. And let's download Kibana. Kibana is a web application that will allow you to look into Elasticsearch. Here, Kibana is a Node application and actually ships with Node, so you're going to have to download the correct version for your platform. So depending on what that is, you select the correct one. So there you're going, and then we'll also download a beat. And so a beat is to get data into Elasticsearch, and what I'll show is packet beat. And packet beat is a beat to get network traffic data into Elasticsearch. And these are written in Go, so here too you're going to have to select the right distribution for the platform. So we'll get started. By unpacking everything. And we'll start Elasticsearch. So this is a JVM application, and what Devin mentioned about startup time, it's true, the JVM really does not take a long time to start up. So we'll check if this is working. And so here is our response from Elasticsearch. And you'll notice that this is JSON. All the APIs in Elasticsearch will work with JSON. So they'll accept a JSON message as a REST request, and they will return a JSON response with the result. And in this case, this is basically just a status message saying it's working. So Elasticsearch is running. Now let's start up Kibana. So Kibana is a Node app, and the first time you start it up, it will compile all the JavaScript code into bundles. So basically, when you start up Kibana, this is what you'll see. It's basically an application with multiple sub-applications, as it were. And we started this up, and it already says, I can't really do anything because even though I'm connecting to Elasticsearch, there's no data in there. I don't know where to find it. So So what we'll do next is actually put data or start putting data into Elasticsearch. And for that we use packetbeat. And here I'm going to cheat what the startup command is because it requires some parameters. And if there's time, I'll also show you some custom configurations as well. But, I'll listen for Alex there. So basically, we're starting a packetbeat, which is an executable. Just means that you'll start it and keep it running. And the C flag is the actual configuration file. And the configuration file basically tells packetbeat what kind of data it needs to push to Elasticsearch. So now my packetbeat is running. So it's listening to all the network requests that this machine, my laptop, is making. So let's just start generating some traffic. So now we made some requests so we know, and they are succeeding, so we know there is definitely packets flowing through this laptop. The nice thing with all the beats too is when you download them is that they come with Kibana dashboards already, and I call them dashboards, but it's actually more. It comes with sort of a configuration for Kibana. So each time you add data to Elasticsearch and you want to see in Kibana, you actually need to tell Kibana specifically where it is. So we're going to cheat here and use one of these prepackaged configurations. So now we have set up our entire stack. So we have Elasticsearch running as our search engine. We have packetbeat listening to network traffic on my computer, adding data to Elasticsearch, and Kibana is ready now to actually query Elasticsearch for that data. And so what the script that I've done has created is created an index pattern. And an index pattern in Kibana language is basically a mapping of your data in Elasticsearch to and the fields in your documents to things that Kibana understands. We'll look first at discover. And this will give you a better sense of what actually is now in Elasticsearch. Discover shows the actual documents that are in Elasticsearch. So we created the packetbeat index pattern, which shows me what documents are in the packetbeat index in Elasticsearch. And every document in Elasticsearch is a JSON file. And basically with fields. And that is what's being indexed, is that JSON context. So if you want to put data into Elasticsearch, you're always going to need some sort of process to create these JSON documents from it. And Beats helps you do that. And the other product that was shown here is a log/2. So those are like sort of the two main ways to do that transformation from your, in this case, network traffic data to JSON, or from file or CSV files or whatever sort of data you have to get into Elasticsearch. Where it gets useful, Kibana is where you create dashboards. And dashboards are views on your data that you define in Kibana. And so that import script that I showed you has dashboards for for that data that we have in Kibana. And for example, here is a view on the amount of documents that are not Elasticsearch. So there have been 35 packets in those few requests that I've been making have been received. We are looking at the last 50 minutes here. I don't know if you can see that, but there's a time where you can select your time range. And we can also set up auto refresh. That starts to become useful when you want to see basically your data change live. So I set up the auto refresh now for 5 seconds. So every 5 seconds, this dashboard is going to update. So here in this bar chart, I'm seeing the number of requests being made because Packetbeat, every request that's being made is putting it in Elasticsearch, so I can track it. If we make more requests, you'll see here the spike of all the resources that were required to load the CNN page. The nice thing about dashboards in Kibana too is that it allows you to filter on your data. So this is a chart that just shows me the number of requests of network traffic, HTTP requests being made. But this shows me the status codes per request. So we have 400, 302, 304s, all kinds. So we can filter on that. So for example, let's filter on 400 codes. Now all my visualizations on my dashboard are adapted to basically the filter that I added is I only want to see 400 response codes. And I got a 400 from a request to the socket.io path. And these filters, yeah, you can remove it. So this is what you get out of the box. This is what it takes to get started with Elasticsearch. If there's time, I can show you some custom configurations, how to do this more in depth. I don't know how it's 5 minutes, alright. So what I'll show you is how to do this from scratch. So, and I'll show you specifically Kibana because most people here I think are web developers, so I'll show you the front end aspect of it. Let's shut everything down. And let's remove our data so we can start clean. So what I want to show you in Packetbeat is that, so all these beats that come with a configuration file and options that you can change. And so if you download Logstash, for example, it'll be a very similar thing. So you'll have configuration files that you then will adapt to kind of data that you want to see. So for this one, what I want to see is I want to have more detailed information on all the HTTP headers that I'm sending so I can do more advanced filters. So for example, and this is an option called send all headers. So what this tells Packetbeat now is not only do I just want to see sort of the metadata about the packets, I also want to see actual about the web request, the HTTP request itself, all the header information. I want to track that as well. So let's start this up again. shortcut to go to the line in GL? Does anyone know?
Put your cursor on it down the bottom right hand corner.
I'm gonna cheat and just click a fresh file. Be very careful not to let it happen. There we go. So let's generate again some traffic. And so when you get started with Kibana, the first thing to do always is create an index pattern. And an index pattern basically maps sort of a configuration in Kibana to an index in Elasticsearch. So in this case, packetbeat creates an index called packetbeat, and what it will do actually with packetbeat is it will create a new index every day. So you have one index per day. The reason for that is it's easier to archive things when your data is in different indexes. So in Elasticsearch, if you say I'm no longer interested in older data, you can then easily discard an index. But in Kibana, you want to query all your data, so you're going to query across indexes, and that's what an index pattern will do for you. So here we basically say, when I make a query to my packetbeat data, I want you to query all the indexes that match all the data. So here we are. In Discover, you can see our data again. So our make sure that we're looking at the last minute instead of auto refresh, so we see it change. And then we can create a say a new visualization. And for example, what we're interested in is say the top hosts that we are requesting. It's weird too. I should maybe take a step back here. Maybe I'm going too quick. But so when you create a visualization here, you see all the different types of visualization that you can make. So when we saw the dashboard earlier with the bar chart and the pie charts and the tables, basically those are selections that we make here. So in the visualize application, we're gonna create each visualization individually, and then we can all put them together on the dashboard. So that's what we'll do now. So if you start with line chart, and that's maybe the easiest one, let me just start with that. We just want to see our our requests over time, and that is sort of a very simple visualization that shows us per minute in this case how many requests we're making. So let's save this. Maybe we want to create a new one where we show the top websites that we're visiting. And this is where the bucket thing, and this is an important thing in the stack too, what a bucket exactly is. It's so when your data is in Elasticsearch, it's in an index and it's organized per document. But all the queries you will make for summaries of data, those summaries are called buckets. And for example, what we did earlier was you make a date histogram, which basically means create a bucket for every minute, create a bucket for every hour, and then it would just count it. So that's why it's called buckets. It's basically like a group by statement. If you're familiar with SQL, it's very similar to that. So in this case, we want to do a term aggregation where we see the our top requests. And here is the so all these headers that you see, that's what we changed in packet beat. So basically we set packet beat not only track my packet info, but also track all the headers in my HTTP request. When you make a query to Elasticsearch too, you always have to size it as well. So in this case, we're interested, say, in the top 100 pages that we requested. So this is basically what we've been seeing the last 15 minutes since we started tracking. So we can save this as well. So we created two visualizations now, so we can create our dashboard. And we just add them to the dashboard. And then you can design them a little, basically, how you want them to look. So this is our simplest dashboard that we can think of, is called top results. You can use those visualizations to filter, so we can see only traffic to data.cnn, for example, which is very little, or only traffic to Louisville.io. And you can also share these results. So now you created your dashboard, and now you want to share this with other people that might be interested in that, just sort of as a report, as it were. You can create a shareable link for that. So basically, if you send an email, for example, you can then copy this link, paste it in that email, and email it to somebody. And then when they visit the link, they see the dashboard that you created. So this is the overview of the stack. So Elasticsearch is at the center. That's your indexer that's going to contain all your documents, and there's
packet analyzer tool. What are some other ones?
FileBeat is one that monitors directories with text files. And so if you have a sort of a process that creates text logs, you can use FileBeat to index that data.
Compared to doing it manually in Logstash?
For example, yeah.
Okay.
So that's this thing for people who are maybe a little bit familiar. It seems like you are. Logstash, you would create almost scripts in Logstash to describe how you want to move your data from A to, basically inside Elasticsearch. Beats tries to be more simple and pick a specific use case and give you a more simple configuration for that. So for example, in package Beat, we saw the configuration to parse out all these headers from your web request was basically just a setting. And so all these themes here, FileBeat, PacketBeat, and LogBeat, MetricBeat, they'll have domain-centric configuration for whatever it is you'll be doing. While in Logstash, you'll write sort of a small script to do what you need to be doing to ingest that data. And that's why I showed Beats, because it has a smaller learning curve, so it's easier to get started with Beats than it is with Logstash.
Does the heartbeat monitoring include the alerting? Because I know there's like an alerting add-on plugin or something.
Yeah, there's overlap. So I
Okay.
think the alerting plugin you're referring to is the one that sits in Xpack.
Something like that.
Yeah. So that's something that I didn't talk about at all, but all this is free. So all these downloads are free. Xpack is actually free too, but it's not open source. And depending on there are different license levels. Depending on the license level you have with Xpack, you'll get more or less. But Xpack are like vertically integrated plugins as well. So the monitoring is a good example. It allows you to monitor your Elastic cluster usage in Elasticsearch, sorry. But it's also not only a plugin then for Elasticsearch, but it comes with the plugin in Kibana then to actually visualize that data you're generating. Similar for security. So if you want to secure your Elasticsearch clusters, you would use a security plugin from Xpack. But then Kibana also comes with a security module that secures Kibana. So that is Xpack. It's for more enterprise users, I would say. So if you're just playing with it, you get really far already with the basic stack. Cloud is something else. It's not something else altogether. It's different. So I showed you how to actually download it and run it yourself. Cloud is this whole thing, the entire stack, all these products hosted for you.
If you want to write programs that hit against Elasticsearch, are there preferred methods for that? I end up just writing shell scripts that have this great big data payload.
To add data to Elasticsearch?
To query it if you want to get back
Yeah.
the number of hits in a given interval.
There's many ways to do it. I guess it depends on what you do, but I think what you're doing is quite right.
It works.
A lot of languages have an Elasticsearch API library.
Or
that-
multiple.
Or multiple. Yeah, exactly. So that helps you too. So I said so everything in Elasticsearch the API is REST, and you will use JSON basically to communicate. It can be a little cumbersome to do that manually. So these language specific libraries will help you do that. So there's one for Java, there's one for JavaScript, there's one for Perl. I mean, quite a few.
To help set up that query. It is handy to use Kibana and then look at what Kibana
Yeah.
shows as its big, long, monstrous.
The Lucene query language that underlies both Elastic and Lucene and Solar is it takes a little bit of a learning curve, but there's some libraries out there that have query builders that make it easier to generate those queries.
Yeah. So what you are referring to is here. So in Kibana, so this is a visualization. Let's start from scratch. So basically, this is a table visualization showing the result of a term aggregation. but it has this little arrow here. Every visualization does. And when you expand it, it shows you more of details what is happening. So what it shows you is a tabular view of your data, which in this case is the same. But for the line chart, you basically see these buckets, in this case all these timestamps with the aggregation result. What it also shows you is the actual request that's made to Elasticsearch to get that data. And that's where sort of the cumbersome part comes in, because if you look at these requests, they're JSON. So they tend to sort of become like a Christmas tree a little bit. And the responses, which is also JSON of that data. So this is useful for if you want to see what's happening.
In a pinch, you just copy paste that, send it in a payload, and you get back the result.
Yep.
Yeah.
Yep.
That was like Web 1.0, right? Your web browser goes to the web server, gets a page, and it's done. Web 2.0 was XML HTTP request, or AJAX, where now the browser can, after it's loading, it can make multiple requests back to the server and get new data. I'm going to go with Web 3.0 was when we had WebSockets. And we had live data going bidirectionally back and forth between the browser, like in a socket fashion. That's how you start getting stuff like chat and stuff in your web apps. And there's this other thing that came around in like 2014 called WebRTC. I'm going to call this Web 4.0. WebRTC is a different looking beast because if you look, there's no server, and it's just a bunch of browsers, and the browsers have arrows and they're talking to each other. And it's the same kind of arrow that you see in like a WebSocket because it's bidirectional. You have one WebRTC connection, you can send data both ways. So WebRTC, what that lets you do is it was built for real-time communications, that's what the RTC stands for, and it lets you send audio and video and data back and forth real-time between browsers. So it's peer-to-peer, meaning it's between you and me and our web browsers, not between a server somewhere. And it all does this all without any plugins or any special software besides just a normal web browser. So it's really cool, and it's not used in a lot of places just yet. It's a little weird trying to start a connection with WebRTC because you can't just go and connect to another random browser. How do you know where that browser is? How do you know that you're allowed to talk to them? That would be a really weird security problem if you could just start talking to random people's browsers and sending them JavaScript or whatever. So they have this thing called signaling data, which are represented by these little hearts. This browser wants to talk to the other browser, and it gets this signaling data ready. They have to share that signaling data with each other in order to like handshake and be able to talk to each other. It's like, hey, I want to give someone permission to talk to me, and then the other browser receives that permission to talk to them, and then says, oh, I'll reciprocate and give you my signaling data back, which gives you permission to start the whole connection. But the problem is, how do you get that signaling data between each other? Because you just have two browsers and they don't know how to talk to each other yet. Usually, what you'll do is you'll use WebSockets to talk to some server somewhere, and that server is like a coordinating server. Everyone knows where Google.com is or wherever some server is, so they can talk to the server, and the server can share the signaling data between the browsers, and then the browsers can go off and do their own thing. So once the signaling data is exchanged between the browsers, they can close the server connection, and then they can continue to talk amongst themselves directly, which is really cool. I use this library that works in both Node.js and the web browser called SimplePeer, which all the articles you'll read about, like WebRTC, will say, hey, don't touch this directly, it's kind of scary. So I use this library, and a lot of them link to this dead library, but this seems to be the best one that I've found. And it's used by something called WebTorrent. So someone built like a BitTorrent downloader thingy that you can put on your website, where browsers talk to other browsers to serve cached versions of your website. So it's like a free web cache for your website based on like BitTorrent technology. But you can download regular files and stuff, and it's all just in the browser, which is really crazy. This is what the code looks like. The code on the left is like setting up a connection. One side of the connection has to be the initiator of the connection, and the other side is not. And then you somehow get the signaling information, and then you get connected. You can send data. WebRTC data channels are the way of like sending raw data. You can send binary data across it. You can send JSON. You can send whatever. It uses a protocol called SCTP, which is kind of it's a configurable protocol that you can make it act like TCP or UDP, which is really freaking cool. Because normally like WebSockets or Ajax or whatever are TCP, meaning you make a request to the server, and the server replies, and it replies with these packets, and they have to be in order, and if pieces of them are missing, it'll resend them, which is good for like downloading big chunks of data or whatever, but it stinks when you're trying to send video or audio or like real-time game information between computers, because if it gets lost, you don't care, you're just going to send a newer version of it anyway. So SCTP can act like either TCP or UDP, and you send in some different settings when you set up the connection, and it works that way, and it's awesome. It's the first time you can build like real-time games in your browser with like little lag. I don't know if you've seen like agar.io or any of those kind of games, those weird IO games you play on your phone or on your on the web, and they're all I think they're just using WebSockets right now, but they could use the peer-to-peer stuff and have better performance. Right now they work mostly in Firefox and Chrome and like the Android stuff. It's hopefully coming down the line soon. And I built a game using this stuff. Which is, I have two web browsers that are talking to each other. This is basically air hockey. So I'm controlling the one on the right, and it's moving on the left. They're just two separate Chrome windows. All they went to is the same URL, and I can send data between them, and now we're playing a game together.
Oh, that was
And
hard.
What's your IP?
That's the first game he's ever won.
Hey, Eric, what's your IP? I'll play you.
Let's all play it.
I'm the same. 192.168.1.48.
Let's see how that congestion control works. Ready? Go.
All right, refresh.
Say WebGL.
Oh, sorry. Refresh one more time. Okay,
There we
so
go.
that's
That's me.
Alex.
Is that WebGL?
It is WebGL.
This is WebGL.
Yeah.
But this is like probably the most seamless and easiest like networked game experience you could ever have. Right here, you just go to a web page in your browser and you're just magically playing against someone else, and you don't have to do anything.
No.
And it just works, and it's awesome.
Who is the broker service that does the signaling?
So I have I just wrote a little Express thing. It's like this much code, and all it does, I can actually show it to you. I lied, it's more than that much code. Oh no, it's 56 lines. Let's make it a little bigger. So this is the server side, and all it does is it's connecting two browsers together, basically. I use this WebSocket server from this WS module, which is a good way to do WebSockets in Node. And when I get a connection, can you guys read that? Should make it bigger. When I get a connection, I see if no one's waiting, I'm gonna stash the current connection away as the waiting player, and then they do nothing. And then once the second player comes, when there is someone waiting, I can pair them up to each other, and this code right here basically hooks the two WebSockets from the two browsers to each other. So now any message coming in from this browser is just going to get bounced over to the second browser and back and forth, and that way they can just send each other their signaling data. And actually that's it. And then it's just that's all there is to it. So I just hook up the two WebSockets, wait for one player, and then once the second player joins, hook their two WebSockets up together, and that's it. So like I could probably run like a bazillion like players off of this one server, because once they get connected, it's not doing anything anymore. So it's like really cheap if you're going to build like a really weird experiment that might get popular. And you can also use it for like video and stuff. And you can actually the simple peer thingy library that I'm using, you can use it on the server side too. So the server can be one. And once you have two browsers connected to each other, you can forward the signaling information from one to another, and then connect a third person to it. Or you can do weird stuff like take that signaling information and turn it into a QR code and text it to someone, and then they can, you can have all sorts of really weird apps with just browsers talking to browsers and no servers. Like no one, you could have like a website that couldn't be shut down. You know what I mean? Like it's just running and there's no permission from anyone, and you could load up a static file and now you're WebRTC connecting to each other. So it's really cool, and it's like super underutilized. There's also another example of a site, I think appear.in is WebRTC, and that's just JSLou. So you can go to appear.in, and it's just a random website. They can you can give them permission to access your webcam. Hello. And then anyone else can go to that same URL, and then now you're video conferencing. You just went to a website, like you don't have to do anything, and you're sending data directly between the browsers, and so it's like fast and all that. So it's like pretty easy. It's a little weird to set the server part up in the middle, but like it really is 50 lines of code, And now like it's like I always thought like the networking the UDP style, like unreliable, low latency networking was like the big missing thing for doing like games, networked games in the browser. You know. So
You didn't make a scoreboard on purpose.
Yeah.
we had a scoreboard and then we broke everything.
Now the game is on.
Smash that thing down.
So yeah, that's WebRTC. You should build something really weird with it.
Like an encrypted dark network or something. It sounds very scary.
You totally could, and it would be awesome. I think encryption is built in between the peers. I'm not 100% sure on that, but I think like the part of the signaling
No, but
information is
the
like
magic
key
is you would build
exchange.
your own. You would have it. You
I
wouldn't.
think there's some sort of SSL or something built into it. You know, there'd be no reason to ever have unencrypted WebRTC, so I think they would just put it in the protocol. And there's stuff, there's support in here for like bypassing firewalls and all that stuff. So you know, just like how Skype does it with all the stun server and ICE server and that weird stuff. You can use public servers to do that or build your own. So
Wouldn't a NAT put like kibosh on the whole thing?
no, it's called like firewall traversal, and there's like ways of like bouncing off of an intermediate server that both parties know of to like get past that.
Well, I mean, if like if I'm A and some other dude is B and the server is C, A and B are going to talk to C, get a